This is the Algebra 1B semester exam review for Unit 4, Topic 2, questions 19 through 37. Remember that you will be given this formula sheet on the exam, so you don't need to worry about making sure that you know all of this stuff. Especially for this topic, we'll be using these forms of the quadratic functions. So this is an important resource to remember. In the table below, a square is shown in the first column. The second column tells what change is made to the length of each side of the square. In the third column, you're going to write the area of the new square in two different ways. So if we have our original square of side length x, what we're actually going to be doing is taking x and adding 3. Because it's a square, we have to do it on both sides. Well, x times 3, 3 times x, 3 times 3. That's what we're going to be doing. So x times x is x squared, 3 times x is 3x, 3 times x is 3x, and 3 times 3 is 9. So there's two ways for us to write the area. We can write it in terms of the side lengths, because remember that area of a square is the side squared. So here we can have x plus 3, the side length, squared. Or we can write it out what makes up the area. And that would be x squared. We have two 3x's, so 6x plus 9. For number 20, we've got our square, and we're going to be subtracting 7 on both sides. So x times x is x squared, x times negative 7 is negative 7x, negative 7 times x is negative 7x, and negative 7 times negative 7 is 49. So the way I can write my area is in terms of the side length. So x minus 7 squared. Or we can write out what makes up the area. X squared minus 7x, which is minus 14x, plus 49. Number 21 says to multiply by 4. So this time I've got my square with my side length of x, but instead of adding or subtracting to that side length, I'm actually going to multiply each side length by 4. So what I'm really going to have is 4 x's going in one direction and 4 x's going in the other. And if I was to fill this in, we'd see that I'd have 16 x's. So in shorthand notation, I've got 4x times 4x. Well, 4 times 4 is 16. X times x is x squared. So my area is going to be 16x squared. I can write it either as my side length, which is 4x squared, or I can write it as 16x squared, which is what the area is comprised of. Last one, I've got my box. I'm going to multiply my x by 2, and then I'm going to add 5. So 2x times 2x is actually 2 times 2, which is 4, x times x, which is x squared. So 2x times 2x is 4x squared. 2x times 5 is 10x, because 2 times 5 is 10, 10x. Again, 2x times 5 is 10x. And then 5 times 5 is 25. So I can write it as my side length, 2x plus 5 squared, or I can write what my area is made up of, which is 4x squared plus 20x, 10x plus 10x, plus 25. And there's my table. For items 23 through 25, we're going to fill in the number that completes the square. So looking at, let's do 23 first. We've got an x squared And we always know we're going to have our x squared. And we have 6 x's, which we need to divide evenly. So I'm going to take 3 x's on either side. So we've got 3 x's here and 3 x's here. So how many ones units is it going to take to complete this square? If we count, we've got 3, 6, 9. So it's going to be 9 ones units. Shorthand for this, I would take half of b, so b divided by 2, and I would square it. Well, in this case, b, when I say b, remember I'm talking about y equals ax squared plus bx plus c. So in this case, I'm talking about 6 divided by 2 squared. Well, 6 divided by 2 is 3, and 3 squared is 9. If I want to take this one step further, I can separate this out and find out what my side lengths are. That's called factoring. So to get this x squared box, I have to have a side length of x times x. To get 3 x blocks, I've got a side length of x and a side length of 1. So 1, 2, 3. So this is going to be x plus 3, and same thing on the other side, so x plus 3. So x plus 3 squared will give me x squared plus 6x plus 9. Number 24 is x squared minus 12x plus something. Again, I know I'm going to have the x squared block. It's the only way for me to get x squared. And then I need to take my negative 12 x's and divide them evenly. So negative 12 divided by 2 is negative 6. So I'm going to have negative 6 x's on this side and negative 6 x's on this side. If you think about it, what I'm really trying to do is take out a GCF on either side to figure out what my side lengths are. So what is the largest common factor between x squared and negative 6x? And that's going to be x. If this is going to be a side length of x, and I've got negative 6x blocks, my ones unit's going to be negative 6. Same thing on this side. So if I have negative 6 ones going along here and negative 6 ones going along here, negative 6 times negative 6 is 36. And that is what I'm using to complete my square. As I said, the other way, you could do b divided by 2 and square it. In this case, b is negative 12. Negative 12 divided by 2 squared. Well, negative 12 divided by 2 is negative 6. And negative 6 squared is 36, which matches our answer. Finally, for number 25, this is a little bit harder because b is an odd number. However, I'm still going to make my box. I'm still going to start with my x squared, and then I'm going to take my 7x and divide it in half. Well, 7 divided by 2 is 3.5, so I'm going to have 3.5 x's here and 3.5 x's here. This means my side length has got to be x plus 3.5 times x plus 3.5. To find out what completes the square, I'm going to do 3.5 times 3.5, and I'm going to get 12.25. That is the number I'm completing the square with. I can also do my b divided by 2 squared, which is b is 7. 7 divided by 2 squared. Well, 7 squared is 49. So really when we square a fraction, we square the numerator, we square the denominator. 7 squared is 49. 2 squared is 4. So we get 49 fourths. And if you divide that out, you'll get 12.25. Question number 26 has a graph that represents y equals x squared. We're going to be looking at the graphs labeled 1, 2, 3, and 4 and match the equations listed below with the graphs above. There's 2 things that we need to remember from this. Y is going to equal ax squared. In our parent function, which is up here, a is 1. So in this graph, a equals 1. Everything is going to be based off of this parent function graph. So there's two things we're going to be looking at. If a is positive, the graph opens up. And if a is negative, the graph opens down. So already we know a is going to be positive here and here, and a is going to be negative here and here. The other thing is how wide or narrow the graph is compared to our basic function, which is 1. So if a is between 0 and 1, it's going to be a wider graph. If a is greater than 1, it's going to be a narrower graph. And this is all in comparison to this parent function where a is 1. So if it's wider than this graph, a is going to be between 0 and 1. If it's narrower than this graph, a is going to be larger than 1. So looking at our equations, y equals negative 1/3 x squared. First of all, a is negative in this one. So it's either going to be 3 or 4. Then looking at the 1/3, because with looking at a in this part right here, we really are just talking about the absolute value of a, because the positive and negative part comes in the is it up or down. So with negative 1/3, we know a is negative, so it's going to be 3 or 4. 1/3 is less than 1, so it's going to be wider, and therefore my graph is going to be 3. For b, y equals 4x squared. A is positive, so it's going to be 1 or 2. And a is greater than 1. 4 is greater than 1, so it's going to be narrower. Therefore, it's going to be graph 1. For c, y equals negative 5x squared. A is negative, so it's going to be 3 or 4. But 5 is greater than 1, so it's going to be narrower. And therefore, we've got graph 4. Finally, with d, a is positive because it's y equals 1/2 x squared. But 1/2 is less than 1, so it's going to be wider than the parent function, and therefore graph 2. For items 27 through 31, we're going to write the function in the forms requested. So we have vertex form, factored form, and standard form, and we're given a graph in 27. Let's first look at vertex form. The vertex is the point at which my graph stops decreasing and begins to increase. So my vertex is right here at -1, -4. Vertex form is y equals a times x minus h squared plus k. H is the x value of my vertex, and k is the y value of my vertex. Remember that inside the parentheses, it's always opposite, because x minus is the standard form. So x minus -1 is actually x plus 1 squared. However, k is always the same, so it's going to be -4. Now I need to figure out what a is. I can look at the graph and determine it by seeing, does it go up the standard way, whereas 1 squared means up 1, 2 squared is up 4, over 3 squared is up 9. But sometimes that's really hard to determine, so my recommendation is always to plug in a number. If I'm doing vertex form, I want to plug in any number other than the vertex. So I'm going to plug in 1, 0. This is one of my x-intercepts. I'm going to plug in this point right here. So if I plug in 1, 0, my y is 0 times a, my x is 1, so 1 plus 1 squared minus 4. 0 equals a, 1 plus 1 is 2 squared minus 4. I'm going to add 4 on both sides. 0 plus 4 is 4. 2 squared is 4, so I've got 4 equals 4a. Divide by 4, and a equals 1. Therefore, my vertex form is going to be 1 times x plus 1 squared minus 4, which we don't really need. So just x plus 1 squared minus 4. Now my factored form deals with my x-intercepts. So here's an x-intercept at 1, 0, and here's an x-intercept at -3, 0. My factored form is always of the form y equals a times x minus p times x minus q, where p and q are my x-intercepts. Well, we already calculated that a is 1, so 1 times x minus p times x minus q. Again, in the parentheses, it's always opposite because the standard form is x minus. So x minus, my x-intercepts here are 1 and -3. So x minus 1 and x minus -3, which is x plus 3. So my factored form is going to be x minus 1 times x plus 3. And a common question is, does it matter which one comes first? And the answer would be no. Finally, to get standard form, I'm going to take my factored form and multiply it out. So I've got x minus 1 times x plus 3. Well, x times x is x squared, x times 3 is 3x, x times -1 is -x, and -1 times 3 is -3. So when I add the inside all together, we have x squared, 3x minus x, which is positive 2x, and then -3. Number 28 is going to ask us the same questions, but instead of giving us a graph, it's going to give us this statement. A quadratic parent function, f of x equals x squared, whose graph is translated to the right 4 units and up 5 units. This means that I'm moving to the right 4, which deals with my h, and I'm moving up 5, which deals with my k. This is essentially giving me my vertex. Now remember, h is always the opposite, but right now my vertex is going to be 4, 5. So when I write it in vertex form, y equals a times x minus h squared plus k. I know a is going to be 1 because they don't mention any vertical stretch or compression. So x minus 4 squared, because it's the opposite, plus 5. And that is my vertex, x minus 4 squared plus 5. My standard form I'm going to find by multiplying this out. We got to go by order of operations, which means that we do our parentheses and our exponents first, and then we do our addition. So I'm going to do x minus 4 squared first. X times x is x squared. X times -4 is -4x. X times -4 is -4x. And -4 times -4 is 16. So this is going to equal x squared minus 8x plus 16. That's what gives me x minus 4 squared. But then I want to add 5. So to add 5, I'm finally going to get x squared minus 8x plus 16 plus 5, which is 21. So my standard form is going to be x squared minus 8x plus 21. Finally, for number 29, we're given a table of values. In our table of values, we can see two things. We can see our x-intercepts, because an x-intercept is when y equals 0. So we have x equals -1 and x equals -5. We can also tell what our vertex is. This is our vertex. And the reason we know is that the vertex is where it stops decreasing or increasing and changes direction. So here we can see we're going 0, decreasing to -3, decreasing to -4, but then increasing again back to -3 and 0. The other thing we know is that it's symmetrical, and this is the one lone pair by itself. So my vertex is going to be -3, -4. So if we start with vertex form, again, we have y equals a times x minus h squared plus k. Well, y equals a, x plus 3 squared, because it's the opposite, minus 4. I need to plug in a point, so I'm going to plug in anything other than the vertex. So I'll plug in -4, -3. -3 equals a times -4 plus 3 squared minus 4. -3 equals a. -4 plus 3 is -1 squared minus 4. I'm going to add 4 to both sides to get 1 equals a times -1 squared is 1. So a equals 1. This means our vertex is y equals 1 times x plus 3 squared minus 4, which in the end gives us x plus 3 squared minus 4. Our factored form is y equals a, x minus p times x minus q. Well, we already know a is 1, and our p and our q are our x-intercepts. They're always the opposite, so x instead of -5 is going to be x plus 5, and x plus 1. So our factored form is x plus 5 times x plus 1. Finally, we have to do our standard form. And this one we can just multiply out from our factored form. I'm going to multiply out x plus 5 times x plus 1. Well, x times x is x squared, 5 times x is 5x, x times 1 is 1x, and 5 times 1 is 5. So when I put these together, we have x squared plus 6x plus 5. And that is our standard form. Question 30 gives us the function f of x equals x squared minus 6x minus 7, and it asks us to put it in factored form. This means we need to factor this expression into two binomials, basically meaning we're given the area and we need to find the side lengths of that rectangle. Well, when a is 1, we can look at what multiplies to c, which is -7, but adds to b, -6. So -7, the factors of -7, meaning what two numbers multiply to give you -7, are 1 and -7 or -1 and 7. Well, if we add them together, 1 plus -7 is -6, and -1 plus 7 is 6. Since we want what adds up to -6, we want this first one right here, meaning our factors are going to be 1 and -7. So our factored form is going to be x plus 1 times x minus 7. And if we multiply that out, we'll see that we get x squared minus 6x minus 7. For number 31, we're given a table. I don't see any of my x-intercepts except for this one. This is also my vertex. So that tells me that my vertex is on the x-axis. Well, if I put it in vertex form, I've got y equals a times x minus h squared plus k. Y equals, my vertex is 0, 0. So y equals a times x minus 0 squared plus 0. This means we have y equals a times x squared. I still need to figure out what a is, so I'm going to plug in a number. I'll plug in -110. This means I'm going to have 10 equals a times -1 squared. Well, 10 equals a, and -1 squared is 1, so 1a, basically meaning that a equals 10. Therefore, my standard form is going to be f of x equals 10x squared. For items 32 and 33, we're going to sketch the graph of the function, then give the information requested. So I'm given the function f of x equals -x squared plus 4x plus 5. I need a table of values in order to graph this, And I could plug in different numbers, but if you use your calculator, you can do this very quickly. On your calculator, you're going to press the y equals button. It's in the top left-hand corner. You're going to type in negative x squared plus 4x plus 5. So you're going to have the function y equals negative x squared plus 4x plus 5 in your calculator. And then you're going to press second graph. And that's going to give you a table of values. So it's best to put in a table of values of all the points that can fit on the graph. And this is a 10 by 10 grid. So we're going to have -2, -7, -1, 0, 0, 5, 1, 8, 2, 9, 3, 8, 4, 5, 5, 0, and 6, -7. So I can plot all these points, -2, -7, -1, 0, 0, 5, 1, 8, 2, 9, and then it's going to be symmetrical, so it's going to be 8, 5, 0, and -7. So this is going to get me this graph that's going to look like this. Don't forget your arrows. Now looking at our table or looking at our graph, we can see that our vertex is here. Our x-intercepts are when y is 0. And our y-intercept is when x is 0. We can also see this on our graph because here are our x-intercepts, here's our y-intercept, and here's our vertex. So our vertex is going to be 2, 9. Our line of symmetry is the line that goes through the vertex and splits the parabola in half so that you have a perfect reflection. That's always going to be the x value of the vertex. It's a vertical line, so it's going to be of the form x equals, and in this case, x equals 2. My x-intercepts are x equals -1 or x equals 5. My y-intercept is when y equals 5. Now this is a quadratic function, so my domain, which is a set of all x values that are on my graph, is going to be all real numbers. So you can write it as the r, or all real numbers, or you can do -infinity to +infinity, both with parentheses because we never include infinity. It is not a number. Our range is going to be all of the y values, so going to -infinity all the way up to the y value of my vertex, y is going to be less than or equal to 9. Another way to write this is -infinity to 9, but I'm going to include 9, so I'm going to use a bracket and put a parenthesis around -infinity because I don't include it. The interval on which f of x is increasing is this right here. This interval is always in terms of x's, so it's all of my x values up to 2. So x is less than 2. You can also write x is less than or equal to 2. It doesn't matter when you get to calculus. It will matter a little bit more, but right now it doesn't matter. Or you can write -infinity to 2. And that 2 right here can be a bracket as well if you decide to include it. So if all of my x values at which f of x is increasing are here, these are going to be all of my x values of which f of x is decreasing. So I'm going to have all values of x greater than 2. Or if I want to say x is greater than or equal to 2. Same thing goes that it's going to be 2 to infinity, not including either numbers, or you can put a bracket here if you include 2. Either way, you will get full credit. Question number 33 gives us, it's the same question, but it gives us an equation that's in vertex form. F of x equals 2 times x minus 3 squared minus 8. Well, looking at this, we should be able to tell what the vertex is immediately because we have our h, which is the opposite, and k, which is the same. So our vertex is going to be 3, -8. Our line of symmetry always goes through the vertex, so it's going to be x equals 3. But we need to graph it. So again, I recommend that you just use your table of values on your calculator, type this function in, and what you'll get is 0, 10, 1, 0, 2, -6, 3, -8, 4, -6, 5, 0, and 6, 10. So if we plot those points, 0, 10 is going to be up here, 1, 0 goes here, 2, -6 is here, 3, -8, and then it's symmetrical again. So I'm going to graph this by connecting all the points. Sorry, my graph is obviously not the best. And then we can look at the table or we can look at the graph to see what our x-intercepts are. One is here, because an x-intercept is when y is 0. The other one is here. Our vertex is here. We can also see this on the graph. There are x-intercepts, there's our vertex, and there's our y-intercept. That's when x is 0, so that's right here. So as we said, our line of symmetry is x equals 3. It's this line. Our x-intercepts are x equals 1 or x equals 5. Our y-intercept is y equals 10. Again, it's a quadratic, so our domain is all real numbers, which can be written with the r or -infinity to +infinity. Our range is all of the y values that are on this graph, so everything from -8 and up. So y is going to be greater than or equal to -8 or -8 inclusive, so the bracket, to infinity, exclusive because we do not include it. The interval on which f of x is increasing is right here. So all of my x values from 3 on. So x is going to be greater than 3. Like I said with question 32, you could also say x is greater than or equal to 3. Same thing, you could write 3 to infinity, not inclusive, or you can make this a bracket and say inclusive 3 to infinity. If this is where f of x is increasing, this is where f of x is decreasing, and that gives us all of these x values. So x is going to be less than 3, or x is less than or equal to 3, depending on how you include it, or -infinity to 3, exclusive, or putting a bracket here if you want to include the 3. All right. Next we have, for items 34 through 37, where adding or subtracting is indicated. Well, for 34, we're going to be adding. And I personally like to add vertically. I think it's easier to see. So I'm going to do that. -3x squared plus 4x plus 7. And then I'm going to take my second binomial and line it up with like terms below it. So we have 7x squared minus 3x minus 12. I'm going to be adding these together. So -3 plus 7 is 4. Keep my x squared. 4x minus 3x is 1x. And 7 minus 12 is -5. So this is going to be 4x squared plus x minus 5. For number 35, we have 2x squared minus 5x minus 9 minus 4x squared minus 7x plus 12. Well, I highly recommend that you distribute the negative ahead of time and make it into an addition problem. Plus -4x squared, positive 7x, and -12. So all I've done is distributed the negative so that I can add the two polynomials together. So I have negative 4x squared plus 7x minus 12, and I'm going to be adding these together. Well, 2x squared minus 4x squared is negative 2x squared. Negative 5x plus 7x is 2x, positive 2x. And negative 9 minus 12 is negative 21. So my polynomial is going to be negative 2x squared plus 2x minus 21. Number 36 is x squared minus 4x plus 11, and I'm going to be adding 8x squared plus 11x plus 15. X squared plus 8x squared is 9x squared. Negative 4x plus 11x is positive 7x. And 11 plus 15 is positive 26. So I'm going to have 9x squared plus 7x plus 26. Finally, number 37, we're going to be doing 4x squared minus 9x minus 12 minus 2x squared plus 9x minus 11. Again, I'm going to recommend that you distribute the negative to all of your terms and instead make this a plus negative 2x squared minus 9x plus 11. So I'm going to have negative 2x squared minus 9x plus 11, and I'm going to be adding them together. 4x squared minus 2x squared is 2x squared. Negative 9x minus 9x is negative 18x. And negative 12 plus 11 is negative 1. So my answer is going to be 2x squared minus 18x minus 1. And that's the end of the first part of the Unit 4, Topic 2 of the Algebra 1B semester exam review.